the
Yeah.
video?
Yeah.
No? Oh.
I will
Oh,
record.
yeah, recording.
Yeah,
Yeah.
so I can use it for maybe future for another user. Okay. So what do you know do you know anything about Igor? Did you try to plot anything?
Well, what I know is just plotting um the graph and then changing, variables and then like parameters that I want to look.
Oh, okay, this is
Very
actually this
similar
is
with
all what I need for your work.
what they say?
This is all what I need for your work. I don't need like kind of fitting or you know.
Oh, okay.
It's just I will give you some data like in Excel sheet or text files. I like to plot them.
Oh, so you want me to just plot and then that graph
Yeah,
looks better than Excel? That's
like for example, when you open, you have this Igor here. You go to data here and you load
mm-hmm.
the general text.
Mm-hmm.
And for example, if I go plot, I want to plot this. This graph is in text file. This file here is in text.
Yeah.
Open, then I need to rename. This one is looks like this is like kinetic energy of some element.
Mm-hmm.
Well, I don't know what element this one, kinetic energy, for example.
Mm-hmm.
For XPS, you when you do it like this, you will have like you need to rename name here if it's carbon, oxygen, you know, palladium or anything. And here is the count or the intensity or anything, and you load your waves.
Mm-hmm.
You know all this, right?
Mm-hmm.
Okay. Then if you go to Windows, new graph, and you have all your waves here, all your like tables here.
Yeah.
Yeah, for example, the y-axis here is
Mm-hmm.
yes, it's the intensity,
Mm-hmm.
and for the x-axis is the energy.
Mm-hmm.
I need to do, for example, intensity here is with this kinetic energy here.
Okay.
And you have here your graph.
Mm-hmm.
And then if you want to change the color, you need just to click on the graph. You can do like black. You can change instead of lines. If you want to do lines and markers, you choose your mark here and you see it here.
Yeah.
And if you want to change the X and Y axis, if you want to name them or change to bold, to change the character or anything, you click just on the axis. You have,
Mm-hmm.
and for example, you go to axis label and you just do, for example, intensity.
Mm-hmm.
If you want to change the intensity, you can click here on the font. You can move, because if you move this here, you can see when you are changing. You can do, for
Yeah.
example, area block. You see here intensity area block.
Yeah.
Change the size, and it's if you don't like it, just cancel and or change it. You know.
Mm-hmm.
And here it's the left side. I can go to the bottom side, and for example, I can do kinetic width. Yeah, and you see it here.
Okay.
Yeah. Sometimes what I like as all the time I choose the same parameters here. For example, if I did for the other one Arial black, I go to Arial black font size 24. For example, uh, if I want the x-axis in logarithm scale, I just click here, and it will change it to logarithm scale.
Okay.
Linear, it will be linear here. For here, if I want to add more text to
Mm-hmm.
the left side, you will see as soon as I change here, you see the text they change.
Right.
They have more or less small or large text.
Mm-hmm.
Don't want to, if I don't want the minor text, I will just unclick this and they will disappear. But all the time I choose the minor text. And if you want to change the size of the, you can go to the tick options, tick text and degrees, and you can change, for example, here, if here will not do a lot of change, but there is some data where you can do exponential labels in engineering or scientific. Yeah, for example, measure, if you want to change to 5, you will see it go to 5, the minor to 1. You see it's now, it's, yeah.
I see. Yeah, I think it's very similar to Excel.
Yeah. Sometimes you don't want to, if like I want like to cut the graph, just the table, I can go to axis range and I want to show just until 500, 5,600.
Mhm.
That's the other numbers.
Oh, okay.
That here, the data, it's there, but it's just, I'm not showing there. But if you want to really to remove the data, you need to go to the table.
Mm,
Go to the table and remove the data, definitely.
then how do you reduce the x-axis rather than y-axis value?
Yeah, same thing.
Oh.
On the x-axis here in the top left, you have
Mhm.
either left, which is the intensity, or bottom, which is the x-axis, kinetic energy.
And then change it.
Yeah, left and bottom here.
Okay.
Yeah,
That's
left
good.
is y-axis and bottom is x-axis, and sometimes just to make like the graph nicely, you can go to the axis secant grades. Here, here, for example, this is the position of the ticks. If you want them inside, you can see that they went inside. Look here, those ticks here.
Mhm.
Now they are inside. Now I can put them crossing like this. I'm going to put them outside.
Mhm.
There is, if you want to do a grid, you can just turn it on and you have the grid on your y-axis.
I see.
There is, what is it? I have to show you something. Here for the axis, I can put another line here.
Mhm.
You can go to the mirror and you can do it on, and you have the same x-axis on the other side. And if you don't want to do the text, you can do no text.
Mm,
And I can do also on the top, same thing. And now you have it here in there.
I see.
Yeah. If you want like to give a name here, what
Mhm.
is,
Mhm.
because you need a legend. Sometimes you have more than graph, like you have 5 or 6 graphs,
Yeah.
one on the top of the other. You can go to graph and do add annotation somewhere. Yeah, it's here.
Yeah.
For example, this is XPS carbon 1s, for example, and you will see
Mm,
it's here. I need just to move it. It's here. Yeah.
okay.
Yeah. For example, imagine that you have 2 graphs, you want to do a comparison,
Mhm.
or to add another graph here. Go to graph and do append traces to graph.
Mhm.
For example, let's do the same one. So I know we have the same x-axis and same intensity. Intensity, energy, I do it. It's here, but it's because it's one in the top of the other. It's the same graph. But
Yeah.
to do some kind of like shift or what they call it here
Mhm.
is they call it offset. I want to offset in the y-axis. I can
Mhm.
I can do offset, for example, by 500 counts here or 1,000 counts, for example. And here you can choose which one you are shifting.
Mm, okay.
One here or the red one here.
Mhm.
For example, I can do
Oops. It disappeared.
uh, let me go back. Both are here. No. Sorry, I did the multiplier. I multiplied all those data here by 1000. For that, it goes all the way up. Just to do shift by just 1000 counts, because I see here the maximum is 5600. If I do now this,
Okay, it's a very small change.
actually it disappeared from. Okay, 5000 was okay. No, I didn't put this in automatic. Yeah, I fixed the maximum to 5600. You see here. And when I added 1000 to 500, it will be 6600. Now I need to take this off. I think it should be 5600. Now it will change. I will see when I will do it again. Access now, it's not 5600. Fixed to 5600. I have this comparison, and you can also shift on the x-axis if you want. For example, if you want to shift this, click offset here. When I do that, like every point here you see, it shifted by 10 to the right, and here every point here it was shifted by 1000 to the top. For example, I can also add. I need a legend, so I can go to the legend here. You click, for example, here in the annotation here, and you can go here to, instead of text box, you can go to legend. Show you what is the difference. Where is it? What is the difference between that? Legend. So it shows the difference between the black and when you add legend, it will show you here the difference between the black and the red. And you can change, because here it's because they are same data, but and if you click on it and you come here to text and you can change this. Like, for example, we did like before treatment.
Yeah, you put P after F.
Yeah.
There you go.
Yeah.
Okay.
What I need from you, and even it's what we do actually, even when for your data that you did, even something like that. This is how we publish.
Okay.
If you want to make this bold, we can just go to axis, probably size 30. Just yeah, this is the basic thing. We can do a lot of things with Igor, even like fitting, similar to what we do with Kazaa XPS. For example, if you have this, you can just go to the analysis and you can quick fit and you choose your function.
I see.
Yeah.
Okay.
Yeah. You want to see the table here, one of these windows, new table, you select the table that you are looking for, like intensity. Like if you want to change anything, any number or something. Yeah. Sometimes you have your data, you can even enter them manually or copy paste like from Excel.
Okay.
Here your new table, and you can just write like, or you just copy paste from another table and put it here, and you can click. This is automatic naming is like wave 0, wave 1, wave 2, but you can just do a right click and you can rename it.
Mm-hmm.
Rename. Oops. Yeah. No, not this one. Should see your name. You can do data and do name here, for example, and you choose which one. Wave 0. Now it's wave 0. I can rename it, for example, to like change it from wave 0 to date. Now I will send you like some tables. I need to export them because they are still in the system.
Mm-hmm.
To export them to text file or Excel file,
Mm-hmm.
and you can just do like load them and plot them. The first
Okay.
thing
Do
that
you
I
have any
want
like preferred style or
now, what I
no?
will send you now is really we can only read the data in the Prodigy software, which is the specs software.
Okay.
Want to show them, I need really to do screenshot. There is or save them as graph. But what I want to do is to make nice figures. And especially what I will send you first is, when we measure the temperature in the system, we
Mm-hmm.
a high voltage and we apply emission current and filament current, and we measure the temperature in the sample and the temperature in the manipulator. This is like, you will have a table of 5 columns.
Okay.
Yeah, and we will see that my goal is to see next time, like imagine that. Let me since I'm sharing with you let me go to team viewer.
Mhm.
Actually, I will send you this data here.
Okay.
Yeah. So you see, I stopped my experiment at this level, but I didn't turn off the acquisition of the data. Means all those, it will be nothing here.
Okay.
My goal, for example, if I go, let me take those off. The goal of this experiment, for example, if I read the example, if I put here, you see, you can read the temperature of 785.
Yeah.
This is the temperature in the sample.
Mm-hmm.
The sample is hotter than the temperature in the manipulator, but I want to see what is the correspondence of this. So it's something like here.
Mm-hmm.
We cannot do, but when we plot this on Igor, you can see that you will have the same x-axis. For example, like in these 2 hours here, you will
Mm-hmm.
have a number, and we can know what temperature in the manipulator here.
So
So
you actually want me to plot it in the same graph and then
exactly same graph, yeah,
okay. Sounds good.
yeah. And imagine in the future that the thermocouple is broken. So, and we have very high priority experiment that we need to do. I don't need to vent the system and fix it. I can just come to this, and I know that the temperature in when the temperature in the manipulator is 674, actually in the real temperature in the sample is 797.
Yeah.
Yeah, this is one. I have a lot of this in this data history review, so I have all this that I need to plot, all those.
Mhm.
But I
So
need to
want
export
me
them
to
because
plot all of these data in one graph or?
no, no. For example, every one of these in one graph, not all of them in one graph, because they are different days of experiment.
Um,
Sometimes pressure, but here, this one, yeah, I want these two in the same graph.
oh, so this one and then the one that you showed me before, they are different. So I basically want to combine this graph into the
Yeah,
same.
these two graph, yeah.
Okay.
When I will send you this, you will have something similar to this. You can have X and Y for one plot,
Mm-hmm.
one Y in the other plot, then you do the same graph and you need just to append this, yeah, append this trace to graph. You will have like table,
Mm-hmm.
4 columns. And actually the X columns is the same for both
Mm-hmm.
because I acquired those data in the same time.
Okay.
Yeah, you can see here. Yeah, it's the same time, it's same X axis.
Okay. Sounds good.
Yeah. So now I need just to find a way to export this to you because they are in very weird extension file called SLH that only this program can open this type of file.
Oh.
Yeah, so I need to find a way to, yeah.
Oh, you cannot convert the file type or anything?
I think you see, I did earlier today, and when you can see, yeah, let me go back. There is this button here. You do export to SV, which is like Excel. When I do that, it gives me, you see, when I will save it.
Mm-hmm.
So I don't need all this local time. I will just remove. I need just relative to start. I do OK. Okay, now I will go to open it.
Mm-hmm.
It's this one here. But you see how they export it?
Oh.
Uh, it's all are in the same column, but just they are, if you can see, just there is like comma between the values. I don't want to
Mm-hmm.
comma, I want to be each value in different column. Like instead to have like all these values, how many values I have here? 1, 2, 3, 4, 5, 5. 1, 2, 3, 4, 5 values. I want to be in 5 columns, so it will be easy to plot.
Yeah,
Here
I
they are
see.
all in the same column, just divided by. Really, for now, I don't know how to do that to export this. I can open that. For example, I can show you. I can open that in text file. Open with, for example, this. I have them here, and I tried earlier to open it with Igor, but it cannot recognize this type of, yeah.
Did you try to convert CSV file to Excel file? Actually, CSV itself is not technically Excel.
Mm.
That's more.
Okay, what I will do, I will send you the file and let me know if you can find a way to do it.
Okay, yeah.
Yeah,
Oh,
yeah, I will send it to you.
okay.
Let me export all what I want actually. Uh, what I want is, you see here the emission. I want the emission, the filament, and
Mhm.
voltage. All this, but only the temperature I want them on. Yeah, we will discuss this later if you figure out how to separate those data.
Okay, sounds good.
Yeah. I can put it in the same one here. it to have like, no, it's here.
Mhm.
Do that, and whenever you have like a question about Igor, just yeah, let me know and we can figure out.
Okay.
Yeah.
Thank Yeah. And I actually have some questions.
Yeah.
Yeah. Do you know how to access to the group share drive outside of campus? Like, not actually
Actually,
the.
Jordan did that to in my laptop. I don't know how he did it. He actually installed the shared drive.
What did you say? Sorry.
Jordan, who did that to me.
Mm,
I don't remember. I never did it, but when I asked Jordan and he did it for me.
okay. Like, did he do it for you remotely, or do you actually?
Actually, now I gave him my computer and he did it.
Mm, okay.
Yeah, it's your own computer, right? I think you get this way, yeah, because I think Jordan has Derek has access to the shared drive from home.
Right. Mm, 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 mm.
I don't know. Yeah, it has a name here. Please contact Jordan. He may give you just a link or something or instruction how to do it.
Yeah. Well, I think I can just figure it out.
Yeah,
Kind of.
this one here. He just did this for me.
Okay.
This shared shortcut. I click on it. Sometimes it asks me for my OSU ID and password, and but it's not.
Mm,
This is a shared drive that I have access. Yeah.
okay. And also,
Hmm.
um, you wait, wait for a second. Oh, so you asked me that to find out the paper that talk about like what type of defects in any like TMD materials give the higher like hydrogen evolution reaction performance, right?
Yeah. If you
Yeah,
find some, yeah.
yeah. I just wonder like, do we want that TMD materials to be like do you want the materials to be to know the ratio of the defects, something like for example if it's MOS2, do we want that catalyst to be like, oh, MOS 1.5, that is the most effective like catalyst? Or I found some papers talks about the HER performance, which makes the like defect rich materials, and it doesn't specify the ratio between metals and sulfur atoms.
Mm.
That material like literally just make the defects as they grow in the lab. So I'm not sure like which materials we kind of want to find out. Cause
But why those kind of defects they are very good for HAR?
what do you say? Why these materials so effective?
Yeah.
Because they have like lots of defects in the surface, which means that they have a lot of active surface area in the basal plane. So when they actually introduce the electron, like the voltage in it, that reacts a lot on
But
their
probably they
surface.
mention if they mention if it's not only about density of the defect, but or the geometry or the ratio, but also the type of defect is important. So probably in that work some kind of different type of defect that they are very active. So I'm interested not only of the density of the defect, but also of the type of defect because we can also in our lab
Mhm.
and we can create different type of defects depending of the type of the treatment that we do.
Okay, so we
And
want.
not only MOS2, if you can also found any other 2D materials, not necessarily MOS2.
Okay, so I need 2D materials and then need to find out like which type of defects they introduce.
Correct, yeah.
Okay, yeah, I'll look into it as well then.
Yeah, I remember there is some work on molyselenide and probably also molytelluride, where some type of defect, they call it like wagon wheels or twin grain boundaries. And those type of defect, they show from the STM that they are very active and they are very reactive. They did
Mm,
HER, but I'm wondering if someone did already on that.
mm, okay.
You can look molyselenide and molytelleride.
Mm, Molly what? Selenite?
Selenide, MOSE2 and MOTE2.
Okay.
Yeah.
Sounds good. Thank you.
Any other questions?
No, I think I'm good.
Yeah. Did you find the guy who gave us the tungsten sulfide thin film? He asked me about the data. I told him we only did one, all right?
Yeah, we only did one
But we
measurement.
never did the bulk to compare with.
Mm-hmm. Yeah,
Did,
I would run it, but that COVID
yeah,
situation
yeah,
thing.
I remember that you were ready to do it, but yeah, you stopped at the last minute. Uh, in your report, did you find any report on bulk tungsten sulfide in literature just to compare that he's growing film that they are better than bulk tungsten sulfide?
Uh, I think I need to see the table. Give me one.
Okay, just double check and let me know if you found any HER on bulk tungsten sulfide, and especially that what we got is better than reported bulk tungsten sulfide, or it's very close to some kind of thin tungsten sulfide.
Okay.
This in
Yeah,
his
I think
thesis, yeah.
I need to make sure, but I think I remember it was like similar with the literature value, not like way better or something. But yeah, I'll let you know.
Okay, okay, sounds good. Thank you.
Yeah, you're welcome. Okay, anything else?
That's it. Thank you. Yeah, that's for my side.
Yeah, okay. Thank you for the training.
Okay, no problem. If you have any question about Igor, just let me know. I will send you this Excel sheet now. Try
Mhm.
to figure out how to put it in different columns.
Okay, thanks.
Okay. Thank you very much.
Yep, thank you.
Okay, bye.